Find the area of the given figure. Remember, for a rectangle, it's base times height. And for a triangle, it's half times base times height, or you can do base times height divided by 2. For number 4, we're going to break it up into a rectangle and a triangle. This rectangle is 4 by 8, which has an area of 32. Since this section is 8 and this whole distance is 13, 13 minus 8 means that this length here has to be 5, because 8 plus 5 makes the total length 13. So half of the base times the height. Well, the base is 5, the height of the triangle is 4. Half of 5 times 4 is 10. So the total area of this trapezoid is 42 units squared. Find the area of the triangles and the rectangle. What do you think the relationship is between the volume of the pyramid and the volume of the prism? How many pyramids do you think it would take to fill up the prism? Let's go back and look at the end of the video. The water level here is not quite halfway. Perhaps it would take more than 2 to fill up the prism. So you might be thinking that 3 pyramids would equal 1 of the prisms with the same size, base, and height. Another way that you could write that is that a third of a prism would be 1 pyramid. For example, if we divided both sides by 3, 3 divided by 3 is 1, 1 divided by 3 is a third. So it's just another way to say the same thing. Let's verify that that is correct. So, what is the relationship between the volume of a pyramid and the volume of a prism with the same base and height? This one is a hexagonal prism and a hexagonal pyramid. Do you think that the relationship will change, even if the base and height of these prisms and pyramids are the same as each other? Let's watch and find out. So even though the shape of the base is different, it still requires 3 of the pyramids to make up one of the prisms. When we're talking about area, we use square inches, which can be rewritten as inches to the second power. But when we're talking about volumes, we use cubic measurements, which is a third power, because there's 3 dimensions that we think about. In class, we're going to look at some cards and try and match them. Here they've already been matched for you. We have the same base, a 6 by 6, and the same height of 6. The volume of the prism is 3 times the volume of the pyramid. So if we're looking for the volume, we're going to take that 216 and split it into 3, because it takes 3 of these to make one of those. So this pyramid has a volume of 72 cubic inches. Let's look at the next one. Here I have a triangular prism and a triangular pyramid. The dimensions of the triangle are 6 by 6 with a height of 6 and a height of 6. So since they have the same base and height, the prism is 3 times the pyramid. So we'll take 36 and multiply by 3, because it's going to take 3 of them to make one prism. And that gives us a volume of 108 cubic inches. This one has a 6 by 4 for its base, and they both have a height of 6. 48 times 3 is 144. So the volume of this will be 144, since the volume of the pyramid is 48. This works for other shapes as well. Here we see a trapezoidal base. They have the same base area and the same height. If we're going to go back to the pyramid, we need to divide by 3. So 624 divided by 3 is a volume of 208 cubic inches. We have a hexagonal pyramid and prism. This is a third of the volume, so 234 split into 3 pyramids would mean each one has a volume of 78 cubic inches. And last but not least, we have another prism and pyramid with the same bases and heights. It takes 3 of these to make one of those. So 156 times 3 tells us that the volume of this is 468 cubic inches. In your book on page 367, you have a graphic organizer to help with the prism and pyramid formulas. Let's start out by labeling the bases of the prisms. The bases are like the top and bottom of the prism. Here on the edge, we have a height. And the faces in the middle are called lateral faces. All around the outside edge. Those are all called lateral faces. In this, we have the bases here and here. This would be the height. And to find the volume of a prism, we do the base area times the height. V is the volume. B stands for base area. And H represents the height of the prism. You may also see it written as BA for base area in the formula, depending on your teacher. Now let's move on to the pyramids. The point at the very top of the pyramid is called the apex. The height can either be inside or it can be on the outside of the pyramid. And then the base would be this flat piece along the bottom. To find the volume, it's 1/3 of the base area times the height. V still represents volume. B still represents the area of the base. And H is the height of the pyramid. Here we have a digital interactive. It says a prism is a three-dimensional solid that has two identical polygon regions called bases in what's called parallel planes, so a top and a bottom. The bases are connected by parallelograms or rectangles that have common edges. And the prism consists of the bases, the connecting parallelograms, and all the line segments connecting the two bases that are parallel to common edges in the parallelogram. The height of a prism is the length of the line segment that connects the two planes and is perpendicular in both. So the height is the distance from the top to the bottom, the distance between the bases. Now, a pyramid is a three-dimensional solid that consists of one base and a point that is not on that plane. The way you get a pyramid is all the segments that join the point to the base. The apex of a pyramid is the point where the lateral faces meet. And then the height is from the base to the apex. For problems 3 through 5, find the volume of the solid. Remember, the volume is found by 1/3 of the area of the base times the height. In this case, the area of the base is 22, and the height is 4.5. So we'll multiply these values together and then divide it by 3. 22 times 4.5 is 99. And then if we split that in thirds, that gives us 33. And remember, we use units cubed for volume. Here we're also using a third of the base area times the height. The base area is 25.25 and the height is 5.5. So we'll multiply those together first and then split it into thirds. This is 138.875. And if we split it in thirds, that gives us a volume of 46.29 approximately. Never mind, that one's not a pyramid, so we do not need the third. It's just the base area times the height. So the volume should be 138.875. Because it's not a pyramid, we don't have to by 3. This one is a pyramid. So we have a triangle base, a 6 by 4 triangle. 6 times 4 is 24, but since it's a triangle, we split it in half. So that's 12 is our base area, and our height is 3. 12 times 3 is 36. Then we split it in thirds, gives us a volume of 12 inches cubed. A pyramid has a base, pyramid, 1/3, with an area of 18 square centimeters and a volume of 36 cubic centimeters. Find the height of the pyramid. So our formula is 1/3 the base area times the height. We were told that the volume is 36. So we'll replace V with 36. We're also told the base area is 18. So we'll replace that B with 18. And now we're going to solve it algebraically. 1/3 of 18 is 6. So on the right side we have 6H. And on the left side we have 36. To solve for H, we divide both sides by 6. And we get H is equal to 6. So the height is 6 centimeters. A rectangular pyramid, there's that word again, so we're using the 1/3, has a height of 10. So I'll replace that H with 10. And a volume of 160. Replace the V with 160. The length of the base is 12. Find the width of the base. Well, if the base area for a rectangle is the length times the width, so I can replace this B because the base area is the length times the width. But it told me that the length was 12, so I can replace that L with 12. Now we'll simplify and solve. 12 times 10 is 120. A third of 120 is 40. And then we can divide both sides by 40 to solve it for W. 160 divided by 40 would equal 4. So the width is 4 centimeters. That takes care of volumes of prisms and pyramids for lesson 21.